Hello, everyone, and welcome to today's SANS webcast, Modern AppSec Tools for Modern AppSec Problems. Practical Introduction to the Next-Gen WAF, sponsored by ThreatX. My name is Carol Auth of the SANS Institute, and I will be moderating today's webcast. Today's featured speaker is Kelly Brazil, Web Application Security Expert at ThreatX. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Kelly.
Thank you, Carol. This should be an interesting topic here because if you're listening to this webcast, it's probably because DevOps or the application developers have handed you a new application that they want to deploy, and you're probably thinking that in this new age of app deployment cycles and APIs and things like that, the traditional way of securing these applications don't necessarily apply. So we're going to talk about some new things here, including how applications and application development has changed, and how that affects security and how legacy WAF compares to new techniques that are coming out. And so in that, we'll introduce the next generation WAF, which is an attacker-centric WAF, and we'll talk about that in more detail, what that means. And then finally, show how a next generation WAF can help in defending modern architectures that include APIs and also defending against automated attacks and things like that. So without further ado, we'll kind of jump into it. So if we're talking about modern applications or modern AppSec, there's a lot to kind of think about. First of all, there's many different architectures now. It's not like the old days where you basically put up a web application that had some forms and then you slapped it on a web server and then you're ready to go. Today, you've got your web applications that could be in legacy data centers, they could be in cloud. You could have different parts of the app in different data centers or hybrid cloud environments, things like that. And not only that, but there's different ways to get to the application. So of course, you have the web interface, but you might have mobile interfaces that will typically use APIs to talk in the back end. There's also different applications now, including IoT. So there's web front ends to a lot of IoT devices and things like that just didn't exist before, and that you don't necessarily trust that they are coded correctly. And then finally, the style of deployment is changing quite a bit. So moving from large monolithic applications to microservices, where now the attack surface area is a lot bigger because the application is spread around. There's a lot of different new vectors to attack the application. And more applications equals more work. So typically what we find out in the field is that 90% of the security team's effort is focused on the top 10% of apps. And that's just because there's just not enough manpower to be able to secure all the applications and APIs that are out there with the traditional technologies today. There's just too much tuning and investigation into alerts, and trying to tune down those false positives is a big issue. So it's just not easy, especially with the pace of change. And so the next thing here is that speed and agility is kind of the new mantra for development. So the whole reason that you would have a WAF or want to secure web applications is because developers are human beings and they make mistakes in coding. And so you want to be able to secure the web applications. And as these CI/CD pipelines and agile development cycles compress that development cycle, you start to see code being deployed more and more often. And that's a great thing from a feature perspective, right? And there's a reason why everyone's moving to that paradigm. But at the same time, the faster things go, the easier it is for mistakes to slip in. And that's really what a WAF is all about, is to basically kind of plug those holes and secure the website. But it's a challenge for a traditional WAF to handle all those changes and all those signature tunings and things like that need to be done. So we have a lot of things to talk about here. As everyone's probably aware these days, once you put a web application up on the internet, it almost immediately starts getting scanned. It's almost like you get a free penetration test as soon as you put a website up. If you put a website up in, let's say, an Amazon VPC, within seconds, it'll start getting web attacks to it. These attacks are not just millions of attackers out there manually typing. Of course, these are automated attacks where there's scanners and bots that are just basically looking for these vulnerabilities. So right off the bat, you not only get the sophisticated attackers, but you're getting bombarded with a lot of automated attacks, including bots. The attackers are anonymous as well, so they're typically smart enough to hide behind anonymizing proxies and hop around IP addresses and things like that. Typical type of techniques used to try to evade traditional WAF detections and things like that. And the attack types are diverse, they're across the board. A lot of us think about these as far as the OWASP top 10. You got your injection attacks, your cross-site scripting, and CSRF and XSRF and layer 7 and DOS attacks and all these types of things happening. So, that's pretty typical. But then you've also got sort of the slow and patient attacks, right? That could basically be escalating up a kill chain over a course of weeks or months, right? And that's kind of another evasive tactic, right? Whereas a typical WAF is looking for kind of the obvious signs of attack. Just by slowing down or hopping around IP addresses and stuff like that, it can be easier to evade a traditional WAF. So there's a lot of challenges here that we're meeting. Add on top of that we're all used to your traditional web applications, but really what's starting to happen is that APIs are taking over the world. I think one source said there's 20,000 plus public-facing APIs out there today, and Gartner says that by 2022, API abuses are going to be the most frequent attack vector that result in data breaches. So not just exploits, but actual attacks that result in data breaches. So these are very serious types of attacks. And if you think about APIs, those public 20,000 or so, and we're just in the early stages of this right now, and that's going to be growing. But if you think about a typical web application, there could be 10 or more APIs, inside, behind that application, right? So there's not just the public APIs, but there's also private APIs, and all of these are attack surface area because they're all developed by developers, again, who make mistakes. So it's a big problem that needs to be addressed. And unfortunately, legacy WAF is failing, right? So if you think about the state of security over the past 10 years, we see a lot of technologies that used to be based on signatures that are now moving to other techniques. And so that's one of the issues with traditional WAF is that it's 20-year-old plus technology, and it definitely has made an impact, but at the same time, it's a very cumbersome technology to use because it's based on static signatures that are based on known exploits. And so you can have hundreds of thousands, even millions of these signatures that need to be tuned for your particular application. And with all the new threats that are coming out, so fast and furiously, it's very difficult to keep up with these threats just with a signature-based approach. And also, application environments are a lot more complex today. So it's no longer true that you would typically have a very simple choke point either at a single load balancer or maybe a transit VPC or something like that. We're starting to see microservice architectures where the application can be anywhere and everywhere at the same time, and you don't necessarily want to direct traffic in any one choke point, which kind of goes against the whole architecture that is put in place in the cloud. So we need kind of a different approach to be able to meet DevOps needs there. And then finally, these applications, once you deploy them, it's not a set it and forget it type of thing. They're constantly changing. At ThreatX, we have customers who roll out updates to their application on a weekly or even a daily basis, right? And so having to have the security team go in and monitor for false positives and tuning rules, all the time is just not a really good use of time, and it really creates a huge burden on security teams, especially teams that don't have a lot of layer 7 experience, and just the manpower is really expensive. So there's a lot of issues with the traditional WAF. So what we're going to do is kind of talk about what it means to be a next generation WAF, right? So next gen WAF. And a next generation WAF is meant to, basically completely replace first generation WAF. So anything a first generation WAF can do, next generation should be able to do that plus more. And one of the main things about a next generation WAF is that it's behavior based, right? So getting away from signatures, just like antivirus on your desktop is moving away from signatures and more towards behavior detection, behavior anomaly detections and things like that. And it's true for other technologies as well. The same thing, shift is happening in the WAF space. So, and the key here is that the behaviors need to be relevant for not only the application, so looking for how the application behaves, but you want to also understand how the attacker behaves. And that's a big differentiator and something that needs to be addressed. And the idea here is that by doing those two things, you can get away from this requirement of managing hundreds of thousands of signatures and basically spending your time in this whole false positive OODA loop that is never ending. The next piece is that it's got to be attacker centric. So, who attacks websites? Well, you have users and you have bots and you have human attackers, right? And so what you really are wanting to do is understand the behavior of those attackers, right? Because that's going to really help you understand whether the attacks against the website are just coding errors or accidental, or the intent is specifically to break into the application. So going beyond just anomalies on the application, but understanding across the kill chain, what is this attacker doing? Are they doing reconnaissance? Are they doing a brute force? Are they doing exploits? And whether they're known or unknown. And also actively engaging. So this is kind of a new concept too, because with a traditional WAF, the extent of the traditional WAF is making a block or allow decision. And that decision is made on very little context. It's made on just understanding, the 5 tuple and some layer 7 information of each web request. Whereas what a next-gen WAF should be able to do is to actively engage the challenge and challenge the user or attacker and even deceive them and gather all this intel so we get more context and have more information to make a better block or allow decision. And that should be done over time as well, right? Because of these slow and low attacks. Sometimes within the first packet or the first request whether something's really bad or not, and you can block it then. And sometimes it's hard to tell the intent of the attacker, and you have to look over days, weeks, even months of time until you're confident that this is a good block. And then finally, it needs to be cloud native. I tend to call this being DevOps friendly, right? There's kind of a new sheriff in town when it comes to deploying apps, and that's DevOps. And so one of the worst things you can do is to have DevOps come to you with an application they want to deploy, and then you want to add on a security layer to it. And then you basically need to tell DevOps that, oh, by the way, we need to reroute this traffic, in an unnatural way that doesn't really meet your cloud architecture. That's a really quick way to upset your DevOps team, and it's not going to be a very fun experience after that. So being able to plug into a modern microservice architecture, use not only protect APIs, but also use APIs in the deployment, and stay in step with DevOps. So as the application is changing over time, being able to keep up with those changes without having to change the way the CI/CD pipeline works. So there's a lot of cool things that are addressed with a next generation WAF. So one of the most important things in a next gen WAF is the threat detection model, right? So again, we're used to the traditional WAF, which uses a signature-based approach, very simple technology, not a whole lot of state there, right? Not a whole lot of information is given to the engine when it makes a block or allow decision. Every web request is basically decided upon in isolation. To some extent, there are other things held in context, but there's not a whole lot of state being kept within a traditional WAF. So at ThreatX, what we've developed is a different detection model that keeps a lot of state and basically provides different perspectives of the traffic. And each of these different sensors are providing these signals and showing their perspective of the attack traffic. And all of those together come together to combine into an aggregated risk score over time. So, for example, you have the first thing you do is you profile the application to understand, what is the application, how does it work, what are the normal parameters of how this application works, right? So that's a good first step, but it's not the only thing that needs to be done to have accurate detections. So once the application behavior is baselined, then you use that information to influence the behavioral rules. They're looking for tactics and procedures of the attacker. So you're looking for behaviors at this point, and you're looking for behaviors that are relevant for the application that's being protected. And you're also keeping state at this point. So for every visitor of the application, you're keeping state over days, weeks, even months. And you're comparing all that activity against a kill chain model. And what you're doing is you're looking for escalation up that kill chain. And that's a good indicator of the intent of the attacker, or whether an attacker is a bot or a human being, right? And so instead of just making a block or allow request based on, or decision based on a web request in isolation, now you have a lot more intel on this user of the application to see whether they have malicious intent or if they are just a normal user. And then finally, sometimes that's not even enough. Sometimes you need even more information. And this is where active engagement comes into play. And this is where technologies like fingerprinting can work really well. So basically by using code injection, cookies, things like that, you can understand things like the resolution size of the attacker screen, the browser type, all these different environment type of attributes of the attacker. And what that allows you to do is correlate this behavior as the attacker hops around IP addresses. And then you can correlate all that activity and you're not losing state. And then it allows you to make a more intelligent decision in the future. And then you can also manipulate the flow. So an example of that would be maybe if you start to see suspicious activity, you want to slow down the responses to the attacker. And this can help you understand the persistence of that attacker. And it can also help with layer 7 DOS attacks, right? So slowing down these types of things that look suspicious, but may just be poor coding, so it's not necessarily a false positive. Or it could be protecting an API where maybe you have some really expensive calls that you just don't want being hit 1,000 times a second. You can slow those things down. And then finally, deception is actually a very important piece as well, because now it can help you to understand intent of the attacker. And a lot of times it's very difficult to tell the difference between a human being and a bot. But if you're sending down fake form fields and links and error codes and things like that, and the attacker or the bot hits on those, then it makes it easier for you to understand if this is a normal user or a bot, and raise that risk score appropriately. So there's a lot of things in play here, and the thing that kind of strings them all together or ties them all together is that they are stateful, right? So you're keeping state over a long period of time. And now when you make a blocking or allow decision, whether it's a traditional web application or an API, you have enough information to be confident that you're not blocking something that shouldn't be blocked. And really, at the end of the day, that's sort of the Achilles heel of a traditional WAF, is that oftentimes they just block things they're not supposed to be blocked, false positives. And now it's your job to go through and sift through your logs and figure out what led up to that block and if it's a false positive or not. So there's a lot of chasing ghosts going on there, and a lot of wasted time. So by having all these breadcrumbs in state, you can immediately look at an entity, or an entity is what we call attackers or multiple IP addresses that roll up into a single attacker, and see right away whether something looks, valid or not. So it really saves a lot of time. And we'll look at that in the demo here in just a little bit. So this risk engine, it's basically a decision engine that creates a risk score, and it's an aggregated risk score, again, based on different perspectives. So not just the application perspective, not just the entity perspective, but we're using different techniques like machine learning and heuristics and fuzzy logic and threat intelligence that we're pulling into the system. So all of these things feed into this risk profile. And the idea here, again, is that instead of just using very simple signatures, we're taking all of this intel in to create a risk model that reduces false positives and tracks risk over time. So an entity can go up or down in risk over time based on their behaviors. So this is really key because not all attackers are just behind a keyboard and typing their attacks in real time. There's a lot of automated attacks out there, and these techniques can really aid in detecting and mitigating them. So things like account takeover, credential stuffing, reputational attacks, DOS attacks, things like that. These are all things where this risk profiling and keeping of state can really help in identifying and then also help in blocking these types of attacks. Distinguishing human traffic from automated traffic has always been a challenge. So if you can interrogate that host and understand that its activity does not look like a normal human activity, then that, again, feeds into that risk profile. And now you're not getting just the traditional OWASP top 10, but you're getting those automated attacks as well. So the idea is that you're arming your security operations center with real-time insight to where they can see why legitimate blocks are made, or if there's certain business logic that's being abused that aren't necessarily attacks. It makes it a lot easier to create entity-based rules or behavior rules that can address those and mitigate them instead of just very kind of primitive signatures. So bots are a big deal, but APIs are probably one of the biggest things on the horizon that we need to think about when we talk about application security. So we know about public-facing APIs, right? Like we said, there's more and more of them every day. They're very useful, and they could be used for faster development, mobile apps and stuff like that. But there's also internal APIs, and a lot of times you'll hear of them referred to as microservices. And they're very important because, again, applications are not monolithic anymore. They are multiple microservices that are scaled up and down independently. Each microservice component could be in different data centers. They don't even have to be sitting next to each other, right? So this attack surface area is spread out a lot more. It's not necessarily just a single choke point to be able to secure the application. And they're vital. There's no way to get around it, because how else can you basically support mobile applications, right? So typically you'll have a modern UI, say a dashboard or something like that, or portal that the user uses via the web UI. But then the mobile app isn't necessarily using the web UI, it's using an API behind the scenes. And that API a lot of times isn't being protected by a WAF because the WAF doesn't necessarily understand how to protect the API. So let's just take a look at a modern security architecture here, right? So in the old days, and hopefully you can see my mouse here, in the old days you'd have your users on the internet, and then they would basically go to the web application, and there would be a web application firewall in the flow. And so that makes a whole lot of sense, and that's pretty trivial to protect. But now we have all these APIs, and so you might have another application that's talking directly to APIs, whether they're backend APIs or maybe they're public facing, but a lot of times that traffic is just bypassing the WAF completely. And then on top of that, you might have mobile APIs to support your mobile applications. And again, same thing, those can be completely bypassing the WAF. But it gets even worse on the inside. So, behind every web application, you might have, it's not uncommon to have 10 or more APIs behind that. And each of those microservices are basically scaled up and down, and they could be living in different data centers. And there's all this east-west traffic going on. And that's important traffic to investigate at the layer 7, because there can be a lot of different types of vulnerabilities and exploits that are utilized if someone gets inside and starts kind of poking around in this area here. So there's no logical choke point to put a single WAF appliance or virtual appliance here. So this is definitely something that needs to be addressed with next generation WAF architecture. So here's something that a lot of organizations are doing these days, and we'll use Kubernetes as an example. It doesn't have to be Kubernetes. It could be, you could be doing microservices and just, on top of plain old instances in AWS or Azure or Google Cloud as well. But the idea here remains the same. The idea is that you integrate the application security into the fabric of the cloud application, okay? And so this ensures coverage of these backend APIs and protects that east-west traffic, which is typically just, a lot of times it's gRPC or it's RESTful, JSON RESTful APIs, things like that. And so the nice thing about this architecture is that it scales up and down with the application. So as these microservices are scaled independently, you don't need to worry about a separate security layer that scales up and down as well and managing that. You just scale security along with the application. So I'll go through this just a little bit here. What you see in say this Kubernetes cluster is you have your worker nodes, right? And so you have a bunch of pods and they're spread around the worker nodes, randomly. And so if you look inside of one of these worker nodes at these pods, you can see that you might have a database, you might have a caching service, and then you might have a web server and different web services running. And what these web services correspond to would be internal microservice APIs, like a RESTful JSON API or something like that. And so what you can easily do is what's called a sidecar pattern, where you're actually running the WAF instance on the same in the same pod or the same virtual instance as the web service application. And so that's really cool now because, and Kubernetes is a great example of this, because if your ThreatX WAF sensor is just a container, which we deploy as a container, which makes it very kind of cloud native, you can have multiple containers in a single pod. And if they are basically doing the sidecar pattern to each other, then that means that you can just, if you need to scale up this particular service, say you're a retail company, it's Christmas time, you need to scale up this microservice to handle more customer orders, as you do that, you're automatically scaling your security as well. You don't have to worry about that as the security team, because basically your DevOps team is scaling your security up as needed, and you don't have to worry about that. All you have to worry about is the visibility, making sure, looking to see if there's any odd traffic going on, which will be automatically taken care of. But obviously, you want to always be double checking everything. So that's kind of the architecture, and again, that's a very DevOps friendly architecture. But then we also need to go a step further and have API specific protections in the next generation WAF, because again, we're not just protecting web HTTP, PHP applications and things like that, or JavaScript, but we're also protecting these RESTful JSON APIs and SOAP APIs and things like that. And so some of the things that can be done at this level are, these are very kind of typical API level attacks at the layer 7. So, someone might try to send unauthenticated requests to the backend, so you can block those types of things. You can tar pit layer 7 DOS queries. So if someone's sending attacks to the backend and the backend database is taking longer than normal to respond, since we're, a next generation WAF such as ThreatX is profiling the application, we can see that happening and actually raise the risk score of that entity or even block them. So this is something that shouldn't even require signatures to do. It just works out of the box. And of course, you want to be able to block, injection attacks, SQL injection attacks, and other type of scripts that can be injected inside of JSON parameters. And this is actually an example of this here. So You can see in this example, I'm doing a curl to an API. I'm doing a post, and you can see my data. I'm sending some JSON here, and here's the name. And in the name field, I'm putting in some, some SQL injection here, and so this is going to the API. And so you can see within the ThreatX UI, we're seeing all these injection strings and understanding that this doesn't look good, right? It looks like an injection attack. So that's very important because that's a very similar attack vector as a regular web application. But in order to do this, you need to be able to parse XML and JSON. Blocking API mapping and brute forcing. So being able to see, if someone's just trying to figure out and scan your API and looking for endpoints and scanning for endpoints that might not exist or JSON fields that don't exist, things like that. Those are all things that the Next-Gen WAF should be looking for. And then finally, looking all the way down into the WebSockets. At ThreatX, we have customers that obviously run APIs, but they even go a step further, and they're running these APIs within WebSockets. And to be able to look for these code injection attacks inside of WebSockets is important to them. So again, being able to support APIs no matter how they're deployed is very important. All right, so what I'm going to do here is I'm going to show a quick demonstration. And this is not going to be as in-depth of a demonstration as we would normally give because we're a little bit limited on time today, but we will also be giving a more in-depth demonstration on Thursday. We're going to have another webcast that gives basically the full demonstration of the ThreatX platform. And so we'll have more information on that later, and then I believe that'll be mailed out to you as well. So what I'm going to do is basically just focus on the entities, because like we mentioned earlier, threat entities is a big differentiator for a next generation WAF. So not only profiling the application and understanding the application anomalies, but really keeping state on all of the visitors of the application and looking for malicious things that they're doing. So I'm looking at a 24-hour period here, but we could go back 90 days. Or you could store this information off into a SIM if you needed it longer. But then you can see we're tracking a risk score for all these entities that are hitting the site. And then down here you have lower, middle range entities that are doing suspicious things. And then you've got entities down at the bottom where they might have come in from a bad IP or location, or maybe they're coming in from a Tor exit node or something like that. So there's something suspicious about them that we want to track, but they haven't necessarily done anything yet. And here they're starting to scan the applications or do reconnaissance. Again, nothing that's going to harm the application, nothing that's going to expose private data, but still things where we might want to start doing interrogation and profiling and fingerprinting and tar pitting and things like that. And then finally here up in the red zone is where we're starting to see exploits happening, right? And so that's where you want to start blocking. I have a couple of entities I just want to focus on, just kind of show you what this looks like. So we give each entity a name, and it's an adjective and a pirate name that's concatenated together. But what's really cool about this is that there's higher level analytics going on. So we're actually tracking these entities across customers. And these entities, the name is the same across customers. So our SOC can very easily track bots and things like that. So if I go inside of this particular one, what I wanted to show here is just that we're tracking these entities over long periods of time. So it looks like we first saw this particular entity in the end of December, and we've continued to track it. And its risk level has stayed fairly steady, and we see that its attack state escalated from exploitation to malware communication, and we had 3 temporary blocks over that time. So this is just a very simple example. Hitting a couple different domains. So this is also cross-site correlation that's going on here. But another one that I want to show you is kind of diving into these exploits a little bit more. And abrasive maintenant. And what I wanted to show here is that there's not really a timeline for this guy, because it basically was just in the matter of a 1 or 2 requests at a single point in time. We saw, okay, this is sort of suspicious stuff going on here. But what I wanted to show you is that kill chain escalation, right? So we saw some reconnaissance happening here. We saw some scanning happening here, and then eventually we saw some web application mapping. So again, tracking that kill chain escalation helps us to understand the intent of the actor. And so we can see here, just by looking at this, I can see there's directory traversal going on. This is not good stuff. And so if I were an investigator and I wanted to see, why was this entity temporarily blocked, I could very easily see all that activity that led up to it, all those breadcrumbs. So again, it's really important to have that entity view when you're securing these new style applications, because you need to make decisions based on more than just individual web requests. A lot of information has to be taken into account, including the geo reputation, the intensity. Is it coming in from Tor exit nodes? What other behaviors has that entity done as well? And so by having all these different perspectives of the entity, you can come up with a very accurate risk score, aggregate risk score. Okay, so that's all I wanted to show you in this demonstration today. And then, like I said, there'll be a more in-depth demonstration this Thursday that you can join and get a better idea of how all this works together. All right, and so let me go back in here. So in conclusion, the takeaways from today's talk, and we'll have a Q&A after this, is that there's new types of attack vectors and changes in development cycles. So AppSec is really challenged by this, right? Application development cycles are a lot faster. The types of applications are different, and because everything's kind of sped up, mistakes are happening, and so the need for a WAF has not gone down; it's actually gone up. But the legacy solutions like the signature-based WAFs are obsolete. There's just no way that they can keep up with these threats and the new style attackers and automated attacks and bots. And also, protecting APIs is not really what they are designed for. So there's a lot of deficiencies in the traditional approach, and so that's why next generation WAFs are coming online to address these demands, right? So being able to protect APIs, both back-end and front-end APIs, and also understand the difference between bot and human activity by keeping state over long periods of time. So hopefully that was presented well, and you can kind of understand the need for a next generation WAF there. And again, we're going to have a more in-depth demonstration on Thursday. And so feel free to join that. We'd love to have you, and you can ask any other deeper questions there as well. All right, thank you very much, and I'm going to hand it back over to Carol, and then we're going to do a little Q&A here.
All right, thanks for that great presentation. We have some questions ready for the Q&A. However, if anyone has a question for our presenters, please enter it into the questions window now. Our first question, you may have addressed this, but we'll ask it anyway. Wouldn't actively engaging and challenging attackers provoke them into really wanting to do harm to your systems? What is accomplished by this?
Right, that's a good question. First of all, they're already provoked. They're already attacking you, right? And you're not basically you're not sending out things to the attacker on your own, right? You're basically just responding to things that they're doing. And so the types of things that you're doing aren't going to harm the attacker. All that you're doing is basically tracking the attacker, trying to see if they're hopping around. You're slowing down the attacker. What else? There's, of course, you're blocking the attacker as well, right? Or you're just sending down fake information to the attacker. So you're not doing anything like trying to, blow up their machine or anything like that, right? This is all, very above the board type of stuff that just helps you to gather intel. And a lot of times the attacker is not going to know, right? So if you're sending deceptive information, how would they know that you're doing that? They don't know the application. They're just trying to scan and understand the application. So if you're sending down fake form fields and fake links to them, that's not something that's provoking them. That's just something that they might trip on.
All right, thank you. How do you integrate with web apps, APIs, and can we deploy you as a microservice in our environment?
That's right, yeah. So what's kind of cool is that at ThreatX, our next generation WAF is basically a Docker container. That's our deployment methodology. So, and of course we have ISO images and AMIs and OVAs, and there's a lot of different ways to deploy it. But at the end of the day, it all comes down to a container. And the nice thing about containers is that you can deploy them as code. You don't have to download things and install them. You basically just say in Kubernetes, you just fill out a YAML configuration file and you say, here, go grab this Docker container here and deploy it in a sidecar pattern along with this microservice. So what's great about that is that now to basically integrate ThreatX into your microservice architecture, it's just a few lines of code added to your configuration file, right? You're not having to download the sensor and package it and all this stuff. It just, all you do is you just put a couple lines of code in your configuration file. So it's very DevOps friendly. This is the way DevOps likes to do things, is deploy as code. And so we are cloud native. That's the way we deploy it, and that's again, keeps your DevOps team very happy, and they don't feel like you're imposing an old way of doing things on them.
All right, thanks. Where does RASP technology fit into all of this?
That's a good question. So we are a WAF, a next generation WAF. So our technology is based on reverse proxy, which means that we are not technology dependent. We don't care what type of backend web server you're running, what kind of language or code you're using. It could be written in Rust or Python or PHP. It doesn't matter to us, right? So we can be put in front of any website. A RASP is really good for sites that you are actively developing yourself, and you're basically introducing that runtime application protection into your code. So it's very dependent on the programming language used, the version of web servers, all this type of stuff you have to take into account. For some customers, that's great because that's just part of their development lifecycle. There are disadvantages, right? There's advantages and disadvantages to every approach. What we find is that for some customers, WAF and RASP are complementary, right? Because you don't always, even if you're controlling your own code, you don't necessarily control all the libraries that are being used in your code, right? So there's some places where RASP works really great, and some places where RASP needs to be augmented with more security. And of course, if you have legacy applications that you're not handling, developing the code for, or IoT devices and things like that, those aren't places where you're going to be able to use a RASP when you're going to be using a next-gen WAF.
Okay, thank you. Given that we are looking to support new architectures and DevOps, how integrated or independent should security be in relation to the DevOps process?
So I love this question. The way I always approach this is that you want to be DevOps friendly, right? And you want to be close to it, but you don't want to hand over security to the DevOps team, right? And kind of getting back to the RASP question, the last one, that's sort of what RASP does, is it hands over the security functionality to DevOps and the application developers. And so, of course, I'm biased, but that is an advantage to me of the next-gen WAF, because now you can get very close to the DevOps and AppSec teams and their deployment methodologies, but you're not handing over control. You still have that control, but you're doing it in a way that makes the application developers and the DevOps team very happy, because they don't have to redesign something based on your requirements. You're basically fitting into their requirements. And this allows you to fit into their CI/CD pipeline. The other thing that's kind of nice, and I didn't get into this too much, but with the next generation WAF, since we're learning the application and profiling it all the time, as the developers and DevOps teams deploy new code to production, the WAF is automatically learning all the new form fields and all the new web pages and all the different aspects of the app in real time. And so the cool thing about that is that now you don't have to have a separate kind of signature tuning step in the deployment cycle. And so that's a big deal, because with the traditional WAF, you have hundreds of thousands of static signatures that need to be modified every time the application changes, which is not the case with the next generation WAF because it's automatically learning all the changes in real time.
All right, thank you. It was my understanding that a next-gen WAF was used to supplement a WAF. Is this the case?
Generally, next generation WAF is replacing traditional WAF. So anything a traditional WAF can do, a next generation WAF can do that and more. So you don't need to supplement, but it is possible for them to coexist, at least for a time during some type of a migration or something like that. But typically, a next generation WAF is replacing a traditional WAF.
Thanks. What does a typical migration or implementation look like if I'm replacing my existing WAF?
Oh, okay, well, that one kind of dovetails in the last question a little bit. So if you're migrating, typically you'll just have both running in parallel. The nice thing about web technologies is that it's very easy to kind of A/B test or swap between, right, via DNS or load balancing configurations and things like that. So you can literally have two WAFs running in parallel and then just swap between them via DNS change or something like that, and then you're good to go. So it's actually a very simple migration.
All right, thank you. Can you see raw? Oh, scroll out of view. Sorry. Can you see raw post requests and can custom signatures be made?
Yeah, absolutely. So custom signatures, we call them behavior rules because they get fed into the state of a particular attacker. But yes, you can look at any part of a request down to the body. We can parse the JSON and XML, and you can do simple contains or equals, or you can even get you can even do complex regular expressions within any of those fields. And then you can also look at the response versus the request direction. So there's a lot of, it's a very robust rule matching engine that basically builds the behavior rules, and users have complete access over that.
All right, thanks. Should our web app scanning tools be looking out for APIs?
Yeah, I think so. I mean, the number one reason is just to catalog your APIs first of all. In the old style, you have to kind of figure out where your APIs are, and then put the WAF in front of them. What's nice about a microservices architecture is that you're basically building the WAF into the application, right? So now you don't have to worry if you basically have a process that when you deploy a new microservice that you just deploy the WAF sensor alongside it and say a sidecar pattern, then you're just automatically getting security every time a new microservice is deployed, instead of the security team having to be involved, at a higher level. So yeah, I think that application scanners should be doing that, if not only just for cataloging APIs, but yeah, you can basically stress test the APIs and see if your traditional, your current WAF is doing well, protecting them, but at the same time also, when you put in next generation WAF in, making sure that those protections are also in place.
Okay, thanks. What if the attacker is not only changing IP addresses, but also VMs?
Yeah, so I mean, there's no perfect solution for this, right? So we do the best that we can with fingerprinting. There's also some type of cluster analysis that you can do. So you're basically not just looking at the fingerprinting, but you're looking at fingerprinting along with the behaviors that entity is exhibiting, and you do cluster analysis to further combine that entity, those attackers into a single entity. And so, I mean, we're still improving, right? So what we have today is very good and does a very good job at basically correlating information, but we're always looking at ways to improve that, and that's one of the things we're looking at as well.
All right, thanks. Could this solution be used to defend against insider threats on isolated networks without internet access?
It can. So the sensors themselves are autonomous, and they make their block or allow decisions without having to be connected to, say the ThreatX cloud. The ThreatX cloud does come into play when the sensors come up, because the WAF sensors act like microservices. They're ephemeral. So one of the downsides to a traditional WAF is you have to log into it and you have to configure it, right? Well, that's not the way microservices work. The way microservices work is you put some environment variables in there, and then they pull down their configuration. They can go up and down, right? And that's how our WAF works. So there is a cloud component to it, but it doesn't need constant access to that cloud. It just needs that access to basically pull its configuration. And so that's fine, for the majority of our customers. We do have some customers that have requested that we put that cloud component within their own data center. So that is technically possible for, some larger customers.
Okay, thanks. This next one's kind of long, so I'm happy to repeat. You mentioned watching the behavior of malicious activity, but do you also correlate good behaving agents, authenticated users, for example, and consider that if they make minute malicious looking requests, for example, don't block your true customers?
Right. That is actually one of the benefits of what we're doing, right? Because we'll track an entity, but as you noticed in the demo, there are a lot of entities that were kind of green and yellow. Those are just normal users for the most part that are doing things that look suspicious, but their intent is not malicious. And the reason it could look like that is because it's just the way the application is written. For example, there are a lot of applications that are, quote unquote, poorly written, which will have parameters in the URL that look like SQL commands. Okay. Now, that's not really a great practice, because now it looks like every user of your application is trying to do a SQL injection attack against you. But there are applications that do that, very big applications that do that. So one of the things that is good about us is that because we're tracking the behavior of the entities, even if they are doing suspicious things, they won't necessarily get blocked if they're just suspicious, but they're not actually doing anything bad. Another thing that's interesting about this approach is false positives. Now, one of the main issues with a traditional WAF is that when you have a false positive, it affects all of your users. The traditional example is a false positive at when you're checking out your shopping cart, right? And if you have a false positive there, basically you're losing millions of dollars because nobody can finish their checkout, right? That's kind of like the big fear. The way ThreatX is different is because we're tracking every entity separately, you don't typically get that type of behavior. When we do have a false positive, it's isolated to a single entity, and it's because they're doing something that's out of bounds of the normal users. And so you don't get that sort of emergency hair on fire moment where everyone on the site is blocked because of a false positive.
Okay, thanks. Does a Next-Gen WAF prohibit me from completely leveraging signatures?
No, it does not. So the Next-Gen WAF actually does implement signatures. They're done in a more intelligent way, but you have the exact same capabilities from a signature writing standpoint than as you would with a traditional WAF. It's just you have more capabilities added on to that. So an example would be, instead of writing a signature and having a block or allow action, you could have a targeting action or a tracking action that would just say, okay, just keep state for this type of activity, or slow down the attacker, or send some deceptive information if I see this type of activity. So basically, it gives you the same signature writing tools, but just gives you more types of actions that you can take on the attacker.
Okay, thanks. That's all I see. Do you have any closing thoughts you'd like to share, Kelly?
Well, thank you everyone for your time, and we're looking forward to having you join the more in-depth demo on Thursday. And if you have any questions, feel free to reach out to us. We're happy to help.
All right, thank you so much, Kelly, for your great presentation, and to ThreatX for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. You know what, Kelly? I just saw one more question pop in.
Yeah.
Actually, a couple. Since the Next-Gen WAF appears to be looking at application behavior, it sounds like it would be optimal to utilize this in your development and test environments prior to deployment in production. Is that accurate?
Yeah, and that can be done, and some customers have done that. The issue with test environments, though, is that sometimes they don't get the same amount of traffic as a production environment does. And so to keep false positive and error rates low, we do have to get a significant amount of traffic. And so that can be done. It just has to be planned for to make sure that within your CI/CD pipeline, you're sending enough traffic to the new parts of the application so that the profiling service can run its course correctly.
Great, thank you. Did you ever see an attack where the attacker was aware that a Next-Gen WAF was in between?
I've seen that when we do POCs with customers and we have pen testers, because obviously they know that what we're doing, and so it's kind of funny because I get the comments all the time like, oh wow, that was really cool. I saw you guys were sending me some fake information, or you were slowing me down here. I'd never seen that before. That's the only case where I personally have seen it, is when the attacker is part of a proof of concept and they already know that we're next generation WAF.
All right, well, that's all I've seen come in, so I'll continue with my closing statements. All right, everyone, for a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.